Okay, steps for completing the square is the first thing you want to make sure is a equals 1. So the number in front of x squared has to be 1. If it's not 1, let's say it's a 2, that means you would need to divide every term by 2 to get rid of it. The next thing you want to do is make sure that you move the constant term over to one side of the equal sign and the x squared and x terms on the other side. So you want x squared and x together, the constant term by itself. Once you've done that, you want to complete the square for the x squared and x terms by taking, the number in front of x, remember that's your b value, and dividing it by 2, and then squaring that result. Remember, whatever you do to one side of an equation, you have to do to the other side. So that means if you add 3 to one side of the equal sign, you have to add it to the other side. So that's really important that you remember you can't just add it to one side. That doesn't keep an equivalent equation. Once you do that, you now have a perfect square trinomial on one side of the equal sign that you can factor. And once you've factored it, you can now solve by taking the square root of both sides. Let me just see if I had. Okay, so first of all, I had an example here, and I'm going to solve it underneath each one of these steps. So we have x squared minus 2x minus 35 equals 0. It said make sure a equals 1, which it does, so we're fine. We don't need to do that, so I can write that here if we want. So it equals 1. Then it said to move the constant term to one side of the equal sign. So that means I would add 35 over to the other side, and I'd have x squared minus 2x equals 35. And notice I leave this space here. This is how I'm going to complete the square later on. So we have x squared minus 2x equals 35. And at this point, when you have it written like this, and this is easier when you're not writing it under each step, you're going to complete the square. So that means I'm going to take the number in front of x, which in this case is my -2, divide it by 2, and square it. And remember, whatever you add to one side, you have to add to the other side. So I'm going to write it twice, one on the left and one on the right. And now let's go ahead and simplify that. That simplifies to be x squared minus 2x plus -2 divided by 2 is -1. -1 squared is 1. And on the right-hand side, we have 35 plus 1. Okay, now you have a perfect square trinomial you can factor. So this left-hand side is a perfect square trinomial. I can factor it. I know it's going to be the same two factors, so I go ahead and start right away and just write it as squared like this, instead of writing it twice. And you need two numbers that multiply to be 1, add to be -2. And that happens to be -1. Now here's kind of a shortcut if you want to use this. That number that's going to be here to factor is always going to be what you have inside these parentheses before you square it. That's always what's going to be right here. And you notice -2 divided by 2 is -1, and that's what this factored to be. And then the right-hand side is 36. So x minus 1 squared equals 36. Okay, now you can solve by taking the square root of both sides. So I have x minus 1 squared equals 36. I'm going to take the square root of both sides. And I'm actually going to come up here. So when you take the square root of both sides, you get x minus 1 equals plus or minus the square root of 36 is 6. Now I can add 1 to the other side, and you get x equals 1 plus or minus 6. Now this one's a little bit different. Notice I don't have a radical sign anymore, which means this can be simplified. So I have my two answers. The two answers are 1 plus 6 and 1 minus 6. And we need to simplify this because this just becomes 7 and this becomes negative 5. So these are our two answers. Since I didn't have a radical sign, this actually shows that this was factorable. Okay, so now let's do another example where we are not having to write each step separately. Let's just go ahead and solve it using those steps. The first thing says that a should be 1, which in our case it is. So I can go ahead to step 2, and that means I'm going to leave the x squared and x term. And I'm going to move the negative 21. I'm going to add it over to the other side. I'm now going to complete the square. So you take the number in front of x, which is 10, divide it by 2, and square it. And remember, whatever I add to one side, we add to the other side. And now let's just simplify this. This becomes x squared plus 10x plus 10 divided by 2 is 5. 5 squared is 25. And this is 21 plus 25. A lot of times I see this 25 get forgotten on the right-hand side, so just remember you need it on both sides of the equal sign. This is now a perfect square trinomial that factors. What multiplies b25 adds to b10, or like I said, you can just come up here and look at this inside the parentheses. 10 divided by 2 is 5, equals 46. You take the square root of both sides, and we get x plus 5 equals plus or minus the square root of 46. And you can see 46 can simplify because I want an exact answer. Is there a perfect square that divides into 46? And 4 doesn't, 9 doesn't, 16 doesn't. It doesn't look like it can be simplified. So I'm going to go ahead and just subtract the 5 over to the other side, and I get negative 5 plus or minus the square root of 46. So this is our answer. Okay, we're going to do one more example. We're going to solve x squared plus 3x minus 1 equals 0. So again, a is 1, so I'm going to move my constant term over to the other side. And now I'm going to complete the square. So I'm going to take the number in front of x, which is 3, divide it by 2 and square it. And I'm going to add that to both sides. I'm going to simplify. 3 half squared is 9/4. I'm just going to leave that as a improper fraction right now. I'm going to factor this perfect square trinomial. And this is where using this rule right here is kind of helpful. What multiplies b 9/4 and adds b3 happens to be 3 halves, what you have inside that parentheses. It multiplies b 9/4 and adds to b3. And then I'm going to add 1 plus 9/4 and I get 13/4. Take the square root of both sides. The square root and the squared cancel, and I have x plus 3 halves equals plus or minus the square root of 13 over the square root of 4 is 2. Come over here. Subtract 3 halves over to the other side. So x equals negative 3 halves plus or minus the square root of 13 over 2.